Hey everybody. Got this down pretty much into about 10 minutes, so we should be good. So anybody heard of Postgres, the database? Maybe there's a chance some of you are even using it. So in the open source world, I'm going to assign myself some permission to use the word agent here by giving you some context after Sanjeev's conversation. What I mean by agents is using low-code and no-code pipelines to define pattern matching sequences where different operations are called on, and LLMs will be called on, and then in a series of draw your own rectangles and lines, you have scenarios that go from a prompt to some kind of retrieval and controlling that and making it very deliberate. So my story today is going to focus on using Postgres to do more than transactions and instead focus on agentic analytics. And we do that in a partnership with NVIDIA that we announced at NVIDIA GTC a couple months ago, where we gave this presentation also. So I am going to need some notes because I have a lot more pictures. But the world uses Postgres. It's the world's most popular database, and it's the fastest growing one. One of the reasons is that it works in critical scenarios. We're on version 18 now, decades in. Berkeley authored, the founders are at my company, a couple of them. And it's used for healthcare and energy and financial services and military and policing. And at EDB, we have a major role in Postgres. So along with mentioning agents, I'm also going to have a boring slide, which is talking about my company. We'll get back. So we're the #1 contributor to Postgres. The next 8 people after us together, contributors, are just come in just under how much we contribute. We're even at the point where out at our booth out here in the expo hall, we have a book that we just published with O'Reilly where our technical leadership wrote how to build your own data and AI platform on open source technology. My presentation today is going to focus on how you can do that on your own and how that can be accelerated by using some of the thought products that we have at EDB that are available in a sovereign data and AI platform. But what we've noticed is that 97% of enterprises expect in the next 3 years to get to the point where they're going to be their own data and AI platform. So when we think about the platform that we have, which is EDB Postgres AI built on open source technologies, the platform, as you can see from the diagram, is designed to support users like DBAs, applications like bank apps and dashboards, anything like that. And then these workflows that manifest as agents, which are smart, mutatable, dynamic workers that are going to be leveraging NVIDIA GPUs. This is really exciting because it focuses on heterogeneous data, like Sanjeev mentioned. There's this need for semi-structured, unstructured, lakehouse, transactional data streaming real-time data sources, and this is focused on doing all that. So deploying this can happen because it's done on Kubernetes, focused on standards. Yesterday I did a talk on the 5 key points that you have to think about making yourself sovereign for concepts like security and no-code, low-code, proliferation of tools for everybody, not just IT or analysts or anything like that. So in this platform, it can be deployed through Kubernetes on any of the cloud native engines, and then it can be deployed on Rancher and OpenShift. And then what it does is it allows you to put everything into one place, and then using Apache Spark, you can extend out to use GPUs and contradict the decided limitations of a transactional database to do analytics. So right now, agents are being starved by the fact that you have a database that's trying to keep up with what it was designed for, which is human-type queries. But now you've got AI agents that are just like playing jazz music, and everything's completely crazy, and the database is like, I wasn't designed for this. So we heard about, Sanjeev mentioned concepts around the extensibility of object storage and different ways to handle this. So the main issues is that agents generate these different query patterns, and agent queries are far more complex. And we're hitting ceilings on some of those queries to the point where customers have sufficiently large data sets, and we're going to look at some benchmarks around this that cause do not finish or timeouts. So the ways that you can handle this are to say, hey, I had this really ambitious project, and I'm going to kneecap it and do a small part of it and still say that I did what I was planning to, or you can re-architect your applications or take some other approach. And these things aren't agile, they're brittle, they don't hold up and they don't scale. So when we think about solving this problem, the starting point is to think about a two-tier application where a database application, even though this is grossly simplified, it's here to illustrate the approach. So if we think about a database, we have the front end that delivers to the application and the back end that's going to take care of writing data and retrieving it from some kind of data store. So you can take that and contradict the limitations of a transactional database by working with extensibility, like just so you know, for those that didn't raise their hands, Postgres is an open source database. Anybody can use it, anybody can contribute to it. The vulnerabilities are thoroughly exercised, so instead of one company with closed source, everybody's constantly trying to break it, and all the exploits are shown. So there's a very good chance that it's even safer than something that people can't touch, because if you find something in it, then you don't have to tell anybody about it, and the maker of the database doesn't know about it, and it goes unseen. So in this case, Postgres is extensible. You can put extensions into it, and those extensions can work with other technologies at the database layer. So instead of having security as some kind of thin candy shell around your database that's run by a sidecar service, you can build this in and extend the database beyond what it was designed for active replication, analytics, transparent data encryption, different kinds of things like that. So here what we did is we take the back end by implementing Spark for the compute engine and object storage, and this allows you to horizontally scale your database and contradict the silos kind of maxing out by taking on concurrency and doing more of a NoSQL approach and relieving those bottlenecks. But what we've done is we worked with NVIDIA to take their Apache Spark, their Spark Rapids library, and bake that into Postgres, so that now we can go out and we can leverage GPUs and have the GPUs work on a transactional database so that the noisy neighbors of analytics and transactions can live in the same place. So the solution that we have implements Postgres Analytics Accelerator, which is one of these extensions that EDB authors. And what it does is three things here. First of all, we're going to utilize it to replicate data to a data storage, in this case, a format like Apache Iceberg. Then we're going to take Apache Data Fusion, which is a columnar vectorized data store. And what that does is it takes your data, turns it sideways, and it does what made Google famous, which is making searchably optimized databases where columns are rows and rows are columns. And then we're going to take Spark Connect to offload data sets and do complex distributed queries and joins, offload, and being able to leverage GPUs for that. And we're going to look at some benchmarks. So if we look at the benchmark, this is from an industry standard benchmarking platform. We're going to see the orange is regular Postgres without anything helping. And we see the reason that the market has decided that Postgres is not a good fit for this, because we get to 10 terabytes and we get this do not finish timeout, doesn't work. But what we do is we optimize by using Spark at 10 times, and we get the blue, which is there that follows along the side, and we get significant performance increases. But then when we couple that with Spark Rapids, we can leverage, in this case, it was the L40S GPUs from NVIDIA, and we get 100 times better performance with nothing that shows any signs of approaching a timeout by leveraging GPUs and having them contribute to the query load. The cool thing is we've redone the benchmark since we authored this on the RTX 6000 Pros, and it's 14 times faster on those. So if you can commit your own GPU, you can run your own LLMs and run them all inside of here, you can do these things without the expensive tokens and without the idea that something that I feel very strongly about as a parent, and I wasn't sure if I was going to include this. I really feel like people don't understand that your questions that you ask these endpoints are so much more valuable than the answers that you get. because maybe you're saving 5 minutes or 6 hours of work, or you don't need to hire a fleet of interns to help over the summer. But when you ask open-ended questions and all of your other data is retrievable from the privacy settings on your phone and they're mashed up together, this data is being sold out the back end by a lot of these companies, including your insurance providers. And they could be drawing conclusions. Your competitors could be getting this data and they could completely negate the differentiation you have in these markets. So sovereignty is hugely important right now. Now those comments are arguable, but there's really no regulation to keep them from happening. So when we start with the PGA extension, we replicate to Iceberg, and then we hit those Spark nodes, we think about how we can do this on our own if we didn't have the platform. So we might want to connect to a traditional data warehouse. EDB actually authors another open source product called Warehouse PG. It's a fork of the Green Plum that Broadcom closed sourced. And it's a data warehousing version of Postgres that can take the PGA extension and give you that capability. And then we can accelerate with Spark Rapids on our own to get that 100-time performance. And this is all on your own if you didn't use the platform. Our book covers this at the booth outside, how to build this on your own. You can generate the vectorized forms of your database using our AIDB extension, which is PG vector, but with pipelines for AI and search, semantic search built in. You can expose MCP, those model context protocol endpoints for your databases to work with LLMs. Then you build, deploy, run, and scale, and do this over and over again. And you can absolutely build this on your own, but there's a lot to keep track of and a lot of decisions to make. So what we've done is just to show you the platform, and I know we're standing over here a lot. I'm going to go over here a little bit, sorry. We've made decisions about things that we think are the point solutions that are right here. So we've incorporated for our Iceberg catalog Lakekeeper, which you can think of as a more modern version of Hive Metastore. We've used Langflow. Langflow is the rectangles and lines series of pattern matching operations that allows users without syntax knowledge of coding to be able to put together through a user interface AI agents based on pipelines. And then we can leverage a combination of this Warehouse PG and then Postgres, which can have active-active replication so that synchronous and asynchronous, always-on rolling upgrades can happen. And you have this architecture that's pretty compelling. So just to recap, the last part I touched on is our platform, which is built almost exclusively on open source extensible technologies. And then before that, I covered how you'd be able to do that on your own, which is covered in the O'Reilly book that we have at our booth. Thanks a lot for your time. I don't know if we have time for questions, but I'm 8 minutes into your break, so maybe I can elect for you to talk to me afterwards if you want to.
Well, thank you.
Yeah.
Actually great.
Thanks.